Okay, I'm going to teach you about greatest common factors. Okay, now with numbers, here's an example. Find the greatest common factor of 12, 30, and 46. Now there's method 1. You make a factor tree. So from the number 12, 30, and 46, 12 can break down into 4 times 3, which is 12. And then 4 can break down to 2 and 2. And then 3, you can't simplify that anymore. So that stays as 3. So, when you have two of the same number when making a factor tree, you just keep one of them and disregard the other one when we're talking about greatest common factors. Now, the number 30. A way to break down 30 is 3 times 10. As we said before, 3 doesn't break down into anything else, so we pull that down. And 10 can be brought down to 2 and 5. Okay. Now, 46. It can be brought down or broken down into 6 times 7. And then 7 can't be brought down to anything else because it's a prime number, so it stays 7. 6 can be broken down to 3 and 2. And that's it. So between all of these numbers, the common number is 2 and 3, again 2 and 3, and 2 and 3. Method 2. Make a list. Okay. It's kind of the same, it's just a different way of listing it. So here's 12. You just list all of the ways you can multiply numbers to get a result of 12. So here's one. 2 times 6, 3 times 4, 1 times 12. And that's basically all you can do with that one. Now with number 30, okay, it can be broken down into 1 multiplied by 30, 2 multiplied by 15, 3 multiplied by 10, and 5 multiplied by 6. Okay, and that's basically all you can do. Now with number 46, it can be broken down into 1 multiplied by 46, and lastly 2 multiplied by 23. Now with this, I like to order from least to greatest, except for I didn't with this one, but it works out best because if this, like such as 3 is the highest number on this one, which means you don't have to go past 3 with this one because you know it wouldn't be a greatest common factor, just to save you time. So again with this, just as with the factor tree, I found out that 2 and 3 are my common factors. So you go down here, 3 times 2 equals 6. This is the greatest common factor of 12, 30, and 46. Okay, now I'm going to teach you about how to find the greatest common factor in variables. Here I have a couple examples. Here's example 1. Now, all the variables we have, as one term we have x to the 3rd power, y to the 2nd power, and z to the 4th power. And then x to the 4th and z to the 2nd power in the 2nd term. With the 3rd term, we have y to the 3rd power and x to the 5th power. Okay. First, you would look at the letters or variables that each have in common. So, do each have an x? X, x, x. Yes. Do each have a y? Y? No y. Y. So that would be eliminated. Now, do they each have a z? Z, z. Oh, no z. So, then you would bring it down here to x. Now, to find the greatest common exponent between the x's, you look at all of them. Look, there's x to the 3rd, x to the 4th, and x to the 5th. There, you look to see what each of the variables have. So, there's a 3 and a 3, there's 3 and 4, and there's 3 and 5. In other words, you can't put 4 into 3, nor can you put 5 into 3. So the greatest common factor of that problem, of all the terms, is x to the third power. Okay, here's the second problem, and this one's a little tricky. Since these terms have a number in front of all of them, you have to break it down to see if there's a common factor between the numbers as well as variables and exponents. So, I broke 8 down just like we did in the factor tree up here, because I like to do that one, plus it's easier for me. You can break down 8 into 4 multiplied times 2, and then this one, you can break it down to from 12 to 4 times 3, and 36 to 4 times 9. Okay. I did that because I found that each one can be broken down into 4s, so I just thought that would be easier. Now, 4 can be broken down into 2 times 2, and 2 right here cannot be simplified anymore. 12, when I broke it down to 4 times 3, this breaks down to 2 times 2, and 3 is brought down to 3 because it is prime and cannot be broken down anymore. Now with this, I broke 36 down to 4 times 9, and then 4 gets broken down to 2 times 2. 9 gets broken down into 3 times 3, and 3, as I said before, is a prime number, so it cannot be broken down anymore. So, with all of these final numbers, you can't break them down anymore. What do they have in common with each other? They each have 2 sets of 2 within their final factorizations. So I circled all of them to show them. So I brought that down here. Okay, as we did before in the previous problem with all the variables, we have to look at what each term has in common in considering variables. So each term has an x, 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 and each term has a y, y, y. So you can bring an x and y down there, but we have to find the greatest common factors of exponents. So with the x's, we look and we see we have a 2, a 3, and a 1. Well, can we fit a 2 into a 3? Yes. Can we fit a 2 inside of 1? No. So, and neither can we put a 3 into a 2 or a 3 into a 1. So, the greatest common factor between exponents for the x is 1. So we bring that down here. Then, with the y's, we look and we see y to the third power, y to the fifth power, and y to the fourth power. So, 3 can go into 5, 3 can go into 4, but can 5 go into 3? No. So, 3 is the exponent common in all of the y variables. So we bring down 3. Now, we have to simplify it. Don't forget this. When you have a number raised to the power, any power of another number, you have to simplify that out. So, 2 to the second power would be 4. So, and 1 is common knowledge, it's known. Every variable by itself is always raised to the first power. So, you have 4 times 6 times y to the third power. And that's your answer.